The power supplied by the DC source, to the resistive load shown in the figure, is regulated via a MOSFET. The waveform of the signal, at the MOSFET's gate, determines the power control method. When the signal at the gate is a DC voltage, the MOSFET acts as a variable resistor. As a result, the voltages and current in the circuit have constant values, without harmonics. However, the MOSFET consumes power, in the form of losses. This is the linear method of power control. By applying a pulse width modulation signal to the MOSFET's gate, the MOSFET functions as a switch. As a result, power loss is minimal. However, the voltages and current exhibit a pulsed waveform, meaning they contain harmonics. This is the switching method of power control. When the MOSFET has zero internal resistance, the power delivered by the 12-volt DC source, to the 6-ohm resistive load, is at its maximum, and equal to 24 watts. By adjusting the MOSFET's internal resistance to 6 ohms, via the gate signal, the power delivered to the load drops to 25% of the maximum, or 6 watts. The power losses in the MOSFET are also 6 watts. Therefore, the efficiency is only 50%. This means that, of the 12 watts provided by the source, only 6 watts are utilized. To control the power at maximum efficiency, the MOSFET must be switched on and off, by applying a PWM signal to the gate. To ensure that the power delivered to the load is the same, 6 watts, as with the linear method, the duty cycle of the PWM signal is set to 25%. The waveforms of the voltages across the load and the MOSFET are displayed on the oscilloscope. The current has the same waveform as the load voltage. All quantities have a pulsed waveform, therefore, they contain harmonics, at frequencies that are multiples of the fundamental frequency, which is 50 Hz. The RMS value of the voltage across the load is the same as in the linear method, 6 volt. The same applies to the current, with an RMS value of 1 ampere. In contrast, the RMS value of the voltage across the MOSFET differs from that in the linear method. The active power supplied by the source is equal to the power in the resistive load. However, due to harmonics, the source supplies additional reactive power, which is consumed by the MOSFET. This power does not cause heat loss in the MOSFET, so the efficiency is ideally 100%. The total power supplied by the source again has a numerical value of 12, but in voltamperes, not in watts.